Let's look at this question here. It's a related rate question. A ladder 25 feet long is leaning against the wall of a house. The base of the ladder is pulled away from the wall at the rate of 2 feet per second. Let's look at the situation here, right? That's the picture of the situation. The blue line here is the house. The green line here is the ladder. And the purple line here is the ground. As you can see here, the ladder is sliding away from the house at 2 feet per second. Okay, so let's look at part A. How fast is the top of the ladder moving down the wall when its base is 7 feet from the wall? Okay, so first of all, let's look at what we know, right? What information we know. So part A, we know that the ladder is 25 feet long. Now, let's label this side, right? From here to here, let's label that Y, okay? Here to here. The length of this point to this point is Y. And this point to this point, we call that X. Okay, the ladder is 25 feet long. We do know what X is from the question, right? When the base is 7 feet away from the wall. So we will look at X as 7 feet. So X equals to 7 feet, okay? So from here to here is 7 feet at that time. Okay. What do we know here? 2 feet per second. From the question, this is the rate of the ladder is pulled away from the wall. So what can we denote this as? Well, if this is X here, this is rate of change in the X variable with respect to time. So that means this is dx over dt, right? It's 2 feet per second. What else do we know? Do we know why? It's not given in the question, but we do know that this angle here, the wall of the house formed with the ground, is 90 degrees. That means this triangle here is a right triangle. We can calculate y using the Pythagorean theorem because we know what x is, we know what the hypotenuse is, which is the ladder. So we can say that x squared plus y squared is equal to 25 squared, right? Based on this. Now, x is 7 feet. So we can say that 7 squared plus y squared is equal to 25 squared. Now, 7 squared is 49. Now, plus y squared. 25 squared is, put in the calculator, 25 squared is 625. Now, isolate y. Y squared is equal to 625 minus 49. Y squared is equal to, now 625 minus 49, 576. Now take the square root of both sides. We take a positive number because the length of y needs to be positive. It cannot be negative. Okay, so square root of that, square root of 576 is 24. Okay, so y is 24 feet long. So we can say that y equals to 24 feet when x is equal to 7 feet. Okay, what are we looking for here? How fast is the top of the ladder moving down the wall when its base is 7 feet from the wall? So basically, we're looking for how fast this point of the ladder is moving down. Well, if this side, the wall of the house, we name that, or we label that y, then we're looking for the rate of change of y with respect to time, right? So that would be dy over dt is what we're looking for. So we're looking for dy over dt. Okay, now you have all the information you have that we know, and now you know what you're looking for. So how do you start solving this question here? Now, this is a right triangle. The best way to set up an equation is to use the Pythagorean theorem, which is this one here. X squared plus y squared equals to 25 squared. Now, let's write this as a number. X squared plus y squared equals to 625. Okay. What do you do next? This is a related rate problem, right? So you're looking for dy over dt. That means you have to take the derivative of both sides with respect to time. Let's do that. D over dt x squared plus y squared is equal to d over dt 625. Okay. Now, how do you find the derivative of these two variables here? Now, first of all, the first one, x squared. Since you are taking derivative with respect to time, you're taking the derivative of x with respect to time, right? What you have to do is, you have to take the derivative of x squared first, which is 2x, times the derivative of x with respect to time. You have this component here is because you're not taking a derivative of x with respect to x. You're taking a derivative of x with respect to time. That's why you have dx over dt. Now, plus next, same thing here for y squared. Since you're taking derivative of y with respect to t, so you have to first take the derivative of y squared, which is 2y, times the derivative y with respect to t, dy over dt. Right? Again, you have this component dy over dt. It's because you're not taking a derivative of y with respect to y. You're taking the derivative of y with respect to t. That's why you have this here. Now, equals to, okay, since this is a constant, the derivative of that is 0. Okay, now, what do you know here? You know x, you know y, you know dx over dt. You are calculating dy over dt. That's not a problem. Okay, here, x is 7 and y is 24. So you have this. 2 times 7, now dx over dt is 2 feet per second. So it's 2. Now, notice that dx over dt is positive 2 feet per second. Why? Because if you put this on the Cartesian plane, this side here, right, to the right side, is a positive x direction. So it's a positive 2. Okay? Now, plus 2 times y. What's y? We calculated that equals to 24 feet when x is equal to 7. So this is 24 times dy over dt. We don't know what that is. We're looking for that, right? Okay. Now, this is what you have to do now. Okay. Yeah. Two times 7 times 2 is now 14. 14 times 2 is 28. So 28 plus 2 times 24 is 48 times dy over dt equal to 0. Now, subtract 28 from both sides. You have 48 times dy over dt equals to negative 28. Divide both sides by 48. You have dy over dt equals to negative 28 divided by 48. Now, dy over dt is equal to, well, we can keep this as a fraction, right, to be exact. But reduce this, you have negative 7 over 12. Now the unit is feet per second. Okay, notice that dy over dt is a negative number, negative value. Why? Because the ladder is sliding down, right? In this position, this direction here, this is the y-axis if you put that on the Cartesian plane. If it's going downward, it's going to the negative y direction. So the change of y over time should be negative value. So this makes sense. Okay, so that's the answer to part A. Now let's look at what part B is asking. Part B, consider the triangle formed by the side of the house, the ladder, and the ground. Find the rate at which the area of the triangle is changing when the base of the ladder is 7 feet from the wall. Okay, so we're looking for the rate of change of the area of the triangle, right? This triangle is a right triangle. Now, first of all, let's list out what we know, right? B, what do we know? Again, we know that x is 7 feet. Okay, let me write this better. Right? X is 7 feet again. It's given in the question here. Now, in the case, we know what y is, right? Here, we know that x is 7 feet, and the hypotenuse, which is the ladder, is 25 feet. We can calculate what y is. We know that x squared plus y squared is equal to 25 squared. So x squared plus y squared equals to 625. Again, yeah, x squared is 7 squared plus y squared equals to 625. Now 49 plus y squared is equal to 625, right? So y squared is equal to 625 minus 49. Y squared is equal to 576. Then y is equal to square root of 576. That is equal to 24. Okay? So y is equal to 24 feet. Okay? Okay. What else do we know? What are we looking for here? Find the rate at which the area of the triangle is changing, right? So the change of area with respect to time. We denote the area as A, right? That would be change in area over change in time. dA over dt is what we're looking for. Okay, now in this case, what's the area formula of a triangle? It's usually the base times height divided by 2, right? So the base times height divided by 2. The base is x, the height is y. So we can write that A equals to x times y divided by 2. Okay, now looking at this, right? You know that we're looking for dA over dt. And that's an A here right away, right? You can see that. So what do we do next? Right away, we should just take the derivative of both sides with respect to time. Then you get the left side equal to this, right? And we just have to calculate what the right side is. Okay, let's do this here on this side. So A equals to x times y over 2. Okay. Now, take the derivative of both sides with respect to t. Then right away, this side is basically equal to dA over dt. Now, how about this? Now we know that 1 over 2 is just a constant, so I can move it out here. Now, what do we see? It's like x times y is like a function times another function. It's a product of two functions, right? If we see it that way. But to use the product rule to find the derivative of this. Now, to think about the product rule, we have to consider we're taking the derivative of x and y with respect to t, okay? then it should be done this way. 1/2 times, now, the derivative of, let's say, x first, right? Times y plus the derivative of y times x. Okay, so here, the derivative of x with respect to t. Now, the derivative of x is just 1. But we're taking a derivative of x with respect to t, not with respect to x. So we have to have 1 times dx over dt times y, okay? That's the first part. Now, second part, we keep x as it is, right? Times, now the derivative of y with respect to t, right? So first, the derivative of y is 1, right? Times the derivative of y with respect to t is dy over dt. Okay. That is the same as this. 1/2 times here. Let's do this. Y times dx over dt plus x times dy over dt. Okay, but do we know what dx over dt is? Do we know what dy over dt is? It is not given in part B of the question here. But don't worry, you have it calculated in part A. You have dx over dt equals to 2 feet per second. And dy over dt, you calculate it as minus 7 over 12. Because it's the same thing here. We're asking, right? Part A is 7 feet away from the wall, and part B is also 7 feet away from the wall, okay? So we do know that dx over dt is 2 feet per second. And dy over dt is negative 7 over 12 feet per second. Yeah. Okay. dA over dt is equal to 1 over 2 times, now y we said is 24, times dx over dt is 2, plus x is 7, times dy over dt is negative 7 over 12. Okay, now let's just calculate it. 1/2 times this is 48 plus, oh, since this is a negative, right? So plus and negative is negative. Now minus 7 times 7 is 49 over 12. Now let's just keep the fraction, right? To be exact. 1/2 times, now 48 times 12 is 576 minus 49, right? One half times 527 over 12. We can multiply 2 by 12. We have 527 over 24. The unit is feet square per second because it's area. Okay, so that's the answer. That's the rate of change of the area of the triangle. Okay, now part B is solved. Let's look at part C. Find the rate at which the angle between the ladder and the wall of the house is changing when the base of the ladder is 7 feet from the wall. So the angle of the wall of the house and the ladder will be this one, right? Between the wall and the house and the ladder will be this one here, okay? So let's draw this triangle. Okay, so part C. So this one's x, this one's y, this one is the ladder. So 25 feet. Now, this is the angle we are looking for, the rate of change of this angle here. Now, in the question, in part C, it's given that the base is also 7 feet away from the wall. So we know that x equals to 7 feet, okay? Now, it's a right triangle. We can calculate y. Again, x squared plus y squared equals to 25 squared. And we know that x is 7, so 7 squared plus y squared equals to 25 squared. 49 plus y squared equals to 625. Now y squared equal to 625 minus 49. Y squared equal to 576. Then square root of 526 is 24. Okay, and we know that y is equal to 24 feet. Now what else do we know? Now that's not much information given in part C, right? But we do know that we're looking for change of the angle over time. So we're looking for d theta over dt, right? That's what we're looking for. Okay. How can we set up this equation so that we can do the derivative to find d theta over dt? We can use trigonometry, right? And we know that from this perspective of a right triangle, tan theta is equal to x over y. So we can write that. Tan theta is equal to x over y, right? If we want to find the dt, if we want to find d theta over dt, we just have to take the derivative of both sides with respect to time. Then we will have d theta over dt on the left side, right? Okay. Let's do that. D tan theta is equal to d over dt x over y. Okay. Now, what's the derivative of this with respect to time? Now, first of all, let's look at derivative of tan theta first. Here. Derivative of tan theta by itself. What's that equal to? Now we know that that's the same as derivative of sine theta over cosine theta, right? Because tan theta is equal to sine theta over cosine theta. In this case, it's a function divided by another function. We may have to use the quotient rule. Now, let's recall what the quotient rule is. Derivative of a function divided by another function is the same as, now the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function, or divided by the bottom function square. Okay, now here that will be cosine theta times the derivative of sine theta, which is cosine theta. Now minus the first function, sine theta, times the derivative of cosine theta, which is negative sine theta, divided by the bottom function square, cosine square theta. Now this is cosine square theta. Now minus minus is a plus, would be sine square theta divided by cosine square theta. And cosine square theta plus sine square theta is just 1. So that's 1 over cosine square theta, which is secant square theta. Okay, now derivative of tan theta is secant square theta. We can write this side as secant square theta. Now, since we're taking a derivative of theta with respect to time, not with respect to theta, so we have to multiply by d theta over dt. How about this side? Now, same thing, use the quotient rule, right? But take into the consideration of the derivative, that is dx over dt and dy over dt, right? So the bottom function, y times the derivative of the first function. Now, derivative of x is 1 times the derivative of x with respect to t is dx over dt minus the top function x times the derivative of the bottom function, which is now 1, right? Times dy over dt divided by the bottom function square, so y squared. Now, again, do we know dx over dt and dy over dt? It's not given in part C of the question, right? It's not given here. But don't worry, since it's also 7 feet that we're asking in part C, we can use the dx over dt and dy over dt from part A. So dx over dt is 2 feet per second and dy over dt calculated as negative 7 over 12 feet per second. Okay, continue from here. Okay, let's isolate d theta over dt by dividing both sides by secant square theta. Now, d theta over dt is equal to, now y is 24, times dx over dt is 2, right, feet per second, from the question, minus x is 7, given in the question. Dy over dt is calculated as negative 7 over 12, right, in part A. Now, divide by y squared, which is 24 squared, times secant square theta. What is secant square theta? Now, going back here, secant square theta is the same as 1 over cosine square theta. What is cosine theta? We can easily get the exact value here. Cosine theta would be y over 25. So that is this, right? Cosine theta is y over 25. And y is 24 feet, okay? Yeah. Now, let's put that into here. 1 over 24 over 25 squared. And the reverse of that is 25 over 24 all squared. And that is equal to, what's 25 squared? 625 over what's 24 squared? 576. Okay, so that is secant square theta. Here, 625 over 576. Now, (625) over 576. Okay, let's get the exact value here. d theta over dt is equal to, now this is 48, minus is a plus, 7 times 7 is 49, over 12, divided by, what's 24 squared? 576 times 625 over 576. Okay, we know that this and this cancel out, right? So at the bottom it's only 625. So what is this? 48 times 12, we have 576. Now plus, right? Plus 49 over 12 over 625, right? Like that. Okay. Then what's 576 plus 49? 625. So 625 divided by 12 divided by 625. Now that is the same as 625 divided by 625 times 12. This cancel out. All I left is 112, 1 over 12. And the unit is radian per second because that's angle. Okay, so that's the answer. 2 d theta over dt, rate of change of the angle. Here, in part C. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.